we want to evaluate the line integral along the curve C of f dot differential r, where the vector field f is given here, and the curve C is given by r of t, where t is on the closed interval from 0 to pi. Looking at our notes below, to evaluate the line integral, we'll first write f as a vectored valued function of t using the x, y, and z components of r of t, and then differential r is equal to r prime of t dt. Once we have it in this form, we'll find this dot product and then evaluate. So let's first find f of x of t, comma y of t, comma z of t. Notice x of t equals t, y of t equals sine t, and z of t equals cosine t. So looking at f here, the x component is 4 times z, so in terms of t it's going to be 4 times cosine t. The y component here is negative 2 times y, so in terms of t it's going to be negative 2 times sine t. And the z component here is just negative x, which in terms of t would be negative t. Now let's find r prime of t. So the x component is going to be the derivative of t with respect to t, which is 1. The y component will be the derivative of sine t, which is cosine t. And the z component is a derivative of cosine t, which is negative sine t. Which means the given line integral along the curve C is equal to the integral of the vector valued function f as a function of t, which would be, again, 4 cosine t, comma, negative 2 sine t, comma, negative t. And this is dotted with r prime of t dt. Well, r prime of t is given here, so 1 comma cosine t comma negative sine t dt. The limits of integration for t are from 0 to pi radians. And now let's find this dot product. We're going to have 4 cosine t times 1, that's 4 cosine t. And then negative 2 sine t times cosine t, that's going to be minus 2 sine t cosine t. And then we have negative t times negative sine t, so that'll be plus t sine t. And now let's evaluate this on the next slide. For the next step, let's write this as 3 separate integrals. So we'll have the integral from 0 to pi of 4 cosine t dt minus integral from 0 to pi of 2 sine t cosine t dt, and then plus the integral from 0 to pi of t sine t dt. And now we'll go ahead and integrate. The antiderivative of 4 cosine t is going to be 4 sine t. Here we'll have to perform u substitution, where we'll let u be equal to sine t, and differential u is equal to cosine t dt. So notice in terms of u, all of this would be 2u times cosine t dt is differential u. So with respect to u, the antiderivative would be 2 times u squared divided by 2, or just u squared, which means in terms of t, we're going to have minus u squared would just be sine squared t. Now for the last integral, we'll have to perform integration by parts, where for review, the integration by parts formula is the integral of u dv equals uv minus integral of v du. So for this integral, let's let u be equal to t. So if we let u equal t, then differential u is equal to 1 dt, or just dt. And if u is equal to t, that means differential v would have to be equal to sine t dt. So we integrate to find v. The integral of sine t dt is equal to negative cosine t. So applying the integration by parts formula, this integral is equal to u times v, which would be t times negative cosine t, or minus t cosine t, and then minus the integral of v du, which would be negative cosine t dt, so this becomes plus cosine t dt, which means the antiderivative of the original integral is going to be plus, and then we'll have negative t cosine t, and the integral of cosine t is equal to sine t, so we have plus sine t, and limits of integration are from 0 to pi. Now we'll perform substitution. Let's go ahead and factor out the 4. So 4 times the quantity sine pi minus sine 0 minus, here we're going to have sine squared pi minus sine squared 0. And then here we're going to have plus the quantity negative pi times cosine pi plus sine pi. So all of this minus negative 0 times cosine 0 plus sine 0. So simplifying, sine pi is 0 and sine 0 is 0, so 4 times 0 would be 0. And because sine pi and sine 0 are both 0, this is also 0. And then simplifying here, we're going to have negative pi, then times cosine pi, which is negative 1. Sine pi is 0, so we have all of this minus 0 times cosine 0 is 0, and sine 0 is also 0. So all this simplifies to pi, or as a decimal approximation, we can say it's approximately 3.1416. I hope you found this helpful.